Hello Year 12 and welcome to the video for the second exercise here in MM5 Applications for Trigonometry. What we're looking at today are bearings. Okay, bearings are a way of measuring direction. From north in a clockwise direction. Okay, so here's north, that's 0 degrees because I've moved around 0 degrees from north. East, I have turned 90 degrees in a clockwise direction. And we use what are called a 3-figure bearing sometimes, so 0, 9, 0 degrees, just to make up the 3 figures. This is, of course, south, which is 180 degrees. West is 270 degrees. Okay, and north can be described as 360 degrees as well. Now, northeast would be over here, would be 45. Southeast, 135. Southwest, 225. And northwest is 315 degrees if we need those things. Now, a bit of a tip when we are dealing with bearings, you need a good diagram. And it helps to draw north arrows at all of your different points. It can make it much easier to work out what's happening. North arrows are all going to be parallel, right? They'll point to north. They're all parallel, and that reminds us of some properties. Now, here's a pair of parallel lines and transversal. Remember that these angles here, right, make an F shape, corresponding angles. These angles here make a Z shape. They're equal, they're alternate angles. These angles here make an X shape. They're equal, they are vertically opposite angles. But the property that we probably use the most is that this angle here and this angle here are described as co-interior angles. And they're not necessarily equal, but they are supplementary. They add up to 180 degrees. Right, that's important. We're probably going to use that property a bit. Now, here we go. Here I've got some diagrams, and I want to describe these directions as 3-figure bearings. So 10 degrees more than 180 is 190 degrees. Here, 12 less than 90, 78 degrees. 22 less than southwest, 22 less than 225 is 202. 202.5 degrees, and 67.5 less than 360 is 292.5 degrees. Okay, so that's for each one of those cases. The bearing that we've given describes the angle measured from north in a clockwise direction. Now, here we go. We have a question here with quite a description, no diagram. It helps to read through it a bit carefully, get an idea of what it's going to look like. Now, I have some lighthouse, right? And because the question uses A and B, I'm going to put a C in here. Right, let's call my lighthouse there at point C, and there's my north arrow heading up there. In fact, I'm just going to do my north arrow. No. Grab that. Yeah, there's my north arrow. Always going to have my north arrows there. So A is due east. Right, so I've got a right angle here. This is point A here. And typically I'd have my north arrows everywhere. It's not actually going to make much difference in this example, but nonetheless, it's a good habit to get into. There's A and C, and there's 10 nautical miles between those. Right angles here and here. Now, B travels southeast from the lighthouse, so that's just this direction here, until it is south of A. So that means that I have a line going straight down here. I have a right angle here. I've got a point down here that's called B. And this angle here, well, that's 135, right? Because it's 45 more than 90. I've got 45 degrees here. Means I've also got 45 degrees here. It means that we have an isosceles triangle. Means this side here is 10 nautical miles as well, right? AB, but that's not what I'm trying to find. I want to find the distance of the second ship from the lighthouse. I want to find the length of BC, which I'm going to use by my standard conventions here as a lowercase a, little a, opposite the angle. So, I could use some trigonometry here. Right? I could use trigonometry, but we don't need to because I have two of the sides and I want to find the third. I know that a squared, in this case, equals 10 squared plus 10 squared. So a squared equals 200. A is the square root of 200, which is equal to 14.14 kilometres. Right. Wonderful. There's the first one. Second up, ship sails on a bearing of 130 degrees. That's pretty similar, right? It's pretty similar to the example above, 10 nautical miles. How far south of its starting point? So, starting point this time, A. There's my north arrow. 130 degrees is over in this sort of, it's not going to work, is it? 130 degrees over in this sort of direction here. This is point B, right? 130 degrees here. Whoops. 130 degrees. And I want to know sort of what we could call the southerly component of that journey is. So if that's 130, that's 50 degrees. And I want to know, I'm going to call this point here, I'm going to make it up, call that C there. I want to know the length of AC, right? Which I'm going to put a little, well, by convention, we use a little b when we're using triangles. Capital letters on the corners, right? Lowercase letters on the opposite sides. Right, I've got 50 degrees here. I want to know this one. I know that this here is 10 nautical miles. Okay, so from my angle, 50 here, this is the adjacent side, this is the hypotenuse. Cos 50 degrees equals b over 10. So b is 10 cos 50. And the calculator tells me that 10 cos 50 is equal to about 6.43. .43 kilometres, right? The ship is 6.43 kilometres south of its starting place. 10 cos 50. Rightio. Next up, we've still got two more examples to go here. Lisa walks south 3.5 kilometres, then turns west. Okay, so I know I'm going this sort of direction. It's going to help to start up here. Here's A, my north arrow. She walks south. Down here to B, right, that was 3.5 kilometres. Then she turns west, that's over this way, for 1.2, that's not as far. Right, and at right angles, this is 1.2 over here to C. Now what I want to know is Lisa's bearing from her starting point. So I need to know from her starting point here at A, from north, swinging around the clockwise direction, that it's going to be a bit more than 180 degrees. If this angle here is theta, then my bearing is 180 plus theta. Okay. Now, I could find theta in this right angle triangle because I have its opposite and adjacent sides. So I know that theta is the inverse tan of 1.2 over 3.5. And out comes the calculator again. The inverse tan of 1.2 over 3.5 is 18.92 or 1855 minutes. So the bearing is 180 plus that is 198 degrees 55 minutes. Rightio. We could find the length of that side there too using probably Pythagoras. That would be helpful. Now in example 11 here, I think we're going to find that it's quite a complicated question, and while you could solve it, my video is pushing 10 minutes now, and we are going to find in a couple of lessons a much more efficient way of solving this question. But what I want to do here, right, I just want to draw the diagram for the time being. So, reading through that question, we've got a start point here. I'm going to call my start point A with my north arrow. Don't ever label your points N, because that will be confusing when you've got your north arrows. There's A. Now, the first leg of this journey is at 150 degrees, so that's this sort of way here for 3 kilometers. Now 150 is 30 off 180, so I'm just trying to make it reasonably sort of steep to get things as accurate as possible. 150 degrees. And 3 kilometers long. I'm going to call that point B. Now another arrow up here to north. And I know that this angle in here then is 150 plus 180. So I know that's 30 degrees in here. My diagram's a bit small already. Okay. There's my 150. 30 degrees. And I need to put in here 3 kilometers as well. Right, that's my first leg. My second leg goes from here, from A there, B here. My second leg is 5 kilometers 220, is back this way. So this should take us to somewhere like this. 5 kilometers. Now it's 220 all the way around here. I'm going to ditch that B for the time being. Okay, there's point B. Now it's 220 around there. That means that I've got 30 plus 220 is 250. Altogether it's got to add up to 360. So that means that I have 110 degrees in here. Okay, there's B. This is point C here. What I'm trying to find out is the length of this line AC and this angle in here. Okay, the bearing from C to A, starting at north, looking around to A, I expect it to be a small number. Okay, that's one thing. And the length of AC, right? Well, actually, I'm expecting that to be more than 5 for reasons that I'll explain later on as well. Now, that question is not unsolvable from where we're at, but it's going to require you breaking it up into a few different triangles, right? I would really want to work out how far east I've gone from A to B, and then how far west I've gone from B to C. Right, will tell me how far east I need to go from C back to A. Right, you look at all the east-west parts of that, break it up. You look at all the north-east parts of that, break it up. You can find some more angles here, right, and you'll find there's quite a sort of game involved, right? If I break this up into some other triangles, I will be able to, once I know this part and this part, I can find this angle here, and I can gradually add all sorts of bits and pieces together, and I will eventually piece together all of the solutions to that problem. We can do that where we're at the moment, but for the time being, draw that diagram, leave it there. We're going to come back to it in a couple of days and find a much more efficient way of solving this. We'll be able to solve this in 2 short steps. Righto, that's plenty enough for this video. It's quite long already, but bearings tends to be something that people find challenging, right? Until they've practiced enough. I often find that students find bearings challenging. So watch this video, rewind, watch it again. That'll take half an hour. Watch it sped up. That might take 20 minutes. Okay, and I'll see you in class.